Fascinating Frontiers, episode EHT3 for May 28, 2026. Here's what's happening in space and science today. A neutrino carrying record energy may have been hurled across the cosmos by a black hole-powered blazar. The most energetic neutrino yet detected could have originated in a blazar powered by a supermassive black hole. Researchers suggest the particle was accelerated in relativistic jets before traveling across intergalactic space. Detection relied on observatories that monitor both neutrinos and high-energy gamma rays. Confirmation would strengthen the case that blazars act as efficient cosmic particle accelerators. Additional events will be needed to map the sources with greater precision. The most energetic neutrino ever recorded may have been launched by a blazar's relativistic jet. These jets form when material spirals into a supermassive black hole and is ejected at nearly the speed of light. Detectors on Earth captured the particle's arrival after it crossed billions of light years without interacting. Matching its direction with gamma-ray observations points to a specific class of active galaxies as the source. The open question is whether every such high-energy neutrino shares the same origin or whether multiple acceleration sites contribute. If the Sun were scaled to the size of a basketball, the supermassive black hole at a typical blazar center would be a marble several kilometers across, yet containing the mass of millions of suns. Material falling inward forms a whirling disk that generates enormous magnetic fields. These fields twist and snap, flinging protons and electrons outward in narrow beams that travel for billions of light years. One proton in such a jet can reach energies 100 million times higher than anything produced in human accelerators, all within a region no larger than our solar system. We can measure the resulting neutrinos and gamma rays when they reach Earth, yet no one has fully explained why a fraction of particles gain these record energies while most do not. The precise balance between magnetic reconnection, shock waves, and plasma instabilities remains the missing piece. From cosmic particle accelerators to the engineering challenge of building bigger rockets that could one day carry detectors closer to such sources, SpaceX's redesigned Starship Phi-3 completed its debut flight last week with the upper stage reaching space. Engineers are now reviewing data from the flight to prepare for the vehicle's return to flight attempt. The next mission will focus on demonstrating improved engine performance and booster recovery techniques. Regulators must complete their review before a new launch date is set. Teams at the Texas launch site are already stacking hardware for the follow-on test. While Starship pushes heavy lift boundaries, smaller players are also scaling up through strategic purchases. Rocket Lab has purchased and rebranded Motive Space Systems to strengthen its capabilities in space robotics. The move targets future missions that require precise manipulation on the surface of Mars and other destinations. Motive's existing hardware and engineering team will integrate into Rocket Lab's growing spacecraft division. Company leaders expect the combined expertise to support sample handling and instrument deployment tasks. Development work on new robotic systems is already underway. Corporate moves like this support the same deep space goals that navigation research aims to make safer. A new study demonstrates that pulsars emitting in X-rays could serve as reliable reference points for deep space navigation. The timing signals from these rapidly rotating neutron stars remain stable over vast distances. Researchers simulated spacecraft trajectories using real pulsar data to verify positioning accuracy. The approach could reduce reliance on Earth-based tracking for missions far from the inner solar system. Further hardware tests are planned for future probes. Better navigation helps future missions reach targets like Mercury, where new ice origin theories are being tested. A new study proposes that much of Mercury's water ice arrived in a single slow asteroid impact within one Mercurian day. The impactor would have delivered ice that migrated to permanently shadowed craters near the poles. Modeling shows the timing and velocity allow ice to survive without immediate sublimation. Earlier theories invoked multiple smaller deliveries over longer periods. Follow-up observations by upcoming Mercury orbiters could test the single impact scenario. From Mercury's ancient delivery events to an even older celestial moment that unstopped a war. On May 28, 585 B.C.E., a total solar eclipse reportedly halted 5 years of fighting between the Lydians and the Medes. Greek historian Herodotus recorded that the sudden darkness convinced both sides to negotiate peace and establish a boundary. The event remains one of the earliest documented cases where an astronomical phenomenon directly influenced human conflict. Historians continue to cross-reference ancient records with modern eclipse calculations to confirm the date. While ancient skies surprised people on the ground, modern skies are about to deliver a second full moon this month. A second full moon this month will rise on May 30th, offering observers a narrow window to catch the moment it clears the horizon. Viewers must account for local terrain and exact lunar position to avoid missing the brief alignment. Photographers are advised to scout locations days ahead to capture the moon appearing unusually large near foreground objects. Atmospheric conditions can shift the apparent color and clarity during the event. Clear skies across much of North America should favor early evening attempts. From backyard observing to the satellites that will soon improve weather forecasting from orbit, the Meteosat third-generation Imager 2 satellite has departed France by ship for French Guiana. Once in orbit, the spacecraft will deliver enhanced weather imagery and lightning detection over Europe and Africa. The journey marks the final ground transport phase before integration with its Ariane 6 launcher. Ground teams will perform final checks upon arrival at Europe's spaceport. Launch is scheduled later this year. While one satellite heads to orbit, another heavy-lift rocket is preparing for its first operational mission. Blue Origin has received FAA clearance to launch its New Glenn rocket, carrying 48 Amazon LEO satellites. The mission will be the first time the heavy-lift vehicle deploys broadband spacecraft for the constellation. The booster, nicknamed No, It's Necessary, will attempt recovery after delivering the payload. Launch could occur as early as next week, pending final range approvals. Amazon has reserved 24 New Glenn flights for future deployments. Launch cadence is also tightening on the other side of the country. SpaceX and United Launch Alliance are scheduled to conduct back-to-back launches from Florida facilities. The missions will deliver separate payloads into different orbits on the same day. Weather and range availability will determine the exact order and timing. Both vehicles are already on their respective paths, undergoing final preparations. This marks one of the tighter launch cadences attempted from the state this year. Keeping orbits usable requires active cleanup efforts already underway. The UK Space Agency has completed a year of projects focused on cleaning up defunct satellites and rocket stages. Multiple missions demonstrated capture and deorbit techniques for objects in low Earth orbit. The effort supports international guidelines aimed at limiting future collision risks. Data from these demonstrations will inform the design of operational removal services. Additional funding rounds are expected to expand the program. Cleaning up near-Earth parallels the dust protection work needed on Mars. Engineering firm Stantec has completed studies on protecting habitats and equipment from fine Martian dust. The work focuses on sealing systems and filtration methods that must operate in the planet's low-pressure atmosphere. Prototypes were tested under simulated conditions matching known dust properties. Results will feed into designs for upcoming landers and surface infrastructure. NASA and commercial partners are reviewing the recommendations. Habitat protection research connects directly to long-duration crew health studies. A 10-month stay at an Antarctic research station has highlighted psychological and logistical challenges relevant to long-duration spaceflight. Participants experienced limited communication, confined living quarters, and delayed resupply similar to conditions on a Mars mission. Researchers recorded sleep patterns, team dynamics, and equipment maintenance issues throughout the isolation period. Results are being compared with data from orbital analogs. The findings will help refine crew selection criteria and habitat design. University programs are already supplying talent for the same Mars architecture. A University of Central Florida graduate now works at NASA on systems supporting future human missions to Mars. The engineer focuses on habitat and transportation elements within the broader Artemis to Mars roadmap. University programs in aerospace engineering supplied foundational training for the role. Ongoing collaboration between the school and NASA centers continues to feed talent into agency projects. Additional graduates are expected to join similar efforts. From people to planets, a new technique may soon let us weigh worlds still hidden in their birth disks. Astronomers at the University of Warwick, working with MIT and McMaster researchers, have developed a method to estimate masses of planets still embedded in their birth disks. The technique uses measurable properties of dust rings that form around young stars. Published in the Astrophysical Journal, the approach allows characterization of worlds invisible to direct imaging. Observations with current and future telescopes can apply the method across multiple systems. The team plans to refine the model with additional ALMA data. Space keeps delivering surprises when we watch closely enough. Next time, we'll be watching for follow-up data on the Starship return to flight attempt and new pulsar navigation hardware tests. That covers today's space and science news. Share this with a fellow space enthusiast if you found it interesting. I'm Patrick in Vancouver. See you tomorrow. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.